Hi guys, yeah, welcome back to the new session of operating system programming concepts. And here I am going to describe you something about like Posix threads and AWK. That is a new pattern, which is special purpose programming language that is just used to handle patterns, right, in the text. Okay, all right. So so let's begin and let's say what's a thread, because I have, in my previous lecture I suggest you guys, I have already described about this Posix threads, and including all the examples, the C programming implementations, all are provided there in detail. So I strongly suggest for those students who are who want to know more about Posix threads, they can go through my previous lectures. But I will just outline some brief concept about what is Posix threads and how to use Posix threads. All right. So what is a thread actually? Actually, thread is a sequence of control within a process, right? So when you create a new thread, and if you create a new thread and if you create a new process, that is totally different, because thread and process, they do not match. All right. So when you create a new thread in a process, a new thread of execution gets its own stack and hence the local variables. All right. So it gets its own stack. So just like also if you create a process, each process has their own unique identifier, also thread has their own local variables, and but they share certain variables. There are called global variables, file descriptors, signal handlers, and it also its current directory. All right. So how do we use the Posix threads then? We use Posix threads mostly in C programming language there is some special procedure. There are some steps that you should follow. That is, first you create the thread, second you join the thread, and lastly you exit the thread after you finished your threading actions, right? So how do you create the thread? There is a special function to create the threads, and this is called pthread underscore create, and it has its own input parameters, and one of the most important parameter is this void start routine. Okay, and this is just returning a void and just accepting the void as a parameter. It's simply saying we must pass the address of a function taking a pointer to void as parameter and returning a pointer to void. So it's taking a parameter as a void and also returning parameter as a void. That means it's totally void. All right. So this is it that we like how we create the thread, and some other parameters also include like the thread that you declare and the attributes of the thread. All right, and the void arguments. So we'll just implement that in our programming language. Now the second step is like we have to join the created threads. So we use this function that is integer pthread underscore join, and it has its following parameters that are the declared thread and the thread return variables. So lastly we exit the thread, that is by using this function that is void pthread underscore exit with its accepting the parameter as a return variable, that is a void pointer. So function, so what it does, this exit pthread underscore exit function is doing is terminating the calling thread, so and returning a pointer to an object. All right. So this is some brief concept about how to use the Posix thread, and we'll just implement this in our programming language where I will explain. And what is a AWK then? AWK is a utility that interprets a special purpose programming language that makes it possible to handle simple data, that is reforming jobs easy. So for example, if you want to make changes in the text file where certain patterns appear, patterns can be any patterns, that is related with a string or values or some other things, right? So this is mostly used for like handling patterns, because if you are using some programming language like C programming language to handle such kind of patterns, it is like you have to create a huge blocks of code just to handle such kind of patterns. So this is some kind of utility or tool just to make programming easier. Alright, and actually what it does is searches for the line that contains certain patterns. Alright, and the rule for awk program is to search for one pattern and one action to perform when the pattern is found. So it's like for each pattern one it finds it performs action 1. For each pattern it finds, for pattern 2 it performs action 2. So like for each pattern it finds it it performs one action per pattern. And the basic note that you guys have to understand is like awk is always keeping on processing the input lines in its way until searching for the pattern in a line till the end of the input file is reached. Alright, so it just till the end of the line, okay, end of the file, it is just going to just search. Okay, till end of the line is going to just search for the pattern, and just search for the pattern and perform the action, search for the pattern, perform the action, okay, until it goes reaches the end of the line. Alright, end of the line, and that you guys have to understand. So, and this makes it easier because we do not have to loop. Okay, we don't have to declare our and loop here. So this makes it easier for us. So how do we run awk programs then? There are two ways to run a program. That is, if the program is very short, if our program is very short, then we are just using is like the keyword awk, then with a parameter like parenthesis, that is a single parenthesis, you like include the program, the awk program, very short awk program, and as a parameter you pass as an input file. Any number of input file you can pass. Input file number 1, file number 2, and similarly. Okay, and you have to note that the program consists of format described above. Alright, and described above means what? Like there must be a pattern and the action must be performed. So this must be noted. And if a program is long, it is usually more convenient to put the program in a file and run it as a command like this. So the syntax is awk -f. So this is the option to include the file, and this is the file, the respective file which consists of this awk program. Okay, and this program file will have an extension awk. Alright, AWK. Also this is the important thing. And input file and input file. Just input the file as for your choice. Alright. So how do you read the input files then? There are two ways to read the files also. All input can be read from the standard input. So standard input can be something like you are reading a file, right? So these files can be read from the standard input, that is like from the keyboard or a pipe of the another command, or you guys can read from the files whose names are specified on the awk command line. So this art I am using here is like I am reading from a from the specified awk command line, that is the file is specified specifically. Alright, so in case of reading from files, awk read them in order. So you know, here I included so many files, right? It's just continuous file and so many continuous files. So that means like each will read one file per time. So first reads input file 1, then it starts reading input file 2. So it reads in a sequence. Alright, it doesn't read all at once. They read in an order. So and they go to the next file. So the unit of reading is called records. So they read a file and they just read them in a unit that is called record. So they read, they like store it in a record and process one record at a time. They read one record at a time and they process also one record at a time. So a rare condition which we can get also, there is another method which is called a getLine command method. which we will do in our one of our laboratory. Like we'll use one of our get line commands. I will just show you one of the example to in my next, most probably the next lecture about using the get command. Okay, which will do explicitly input from any number of files. So from the get line command you can just explicitly input from any number of files, and can also be, it's also very convenient to use. And so how input is split into records then? So there are some kind of records, right? As I have told you, the unit of reading that the AWK performs is by using it from the records. So some input, so how input is split into records then? So AWK language divides its input into records and fields. These records are separated by a character called record separator. So this record has some certain kind of delimiter that separates, it's called record separator. Alright, and a default record separator is a new line character. Alright, and one record is a one single line. So you guys, so as a default record separator is a new line character, that means a new line character is going to take you to the new line. That means one record means one line. Alright, so a next line means a next record. Alright, so it's like scanning or reading. AWK is just reading in a line. So one line, it reads one line at a time. Okay, and that just performs one line action. So how do you use? So okay, there are also fields we will describe it, and but also you can, guys can just declare your own built-in variables. Record separator to use a different character. Okay, you can use also your own character to separate your records. Alright, this is this default one, but you guys can also use your own built-in variables. So what is a field then? So fields are something like a record was something that was read in a line, right? But fields are something that are in which that records are automatically parsed into chunks. So they are called chunks. Okay, there are chunks of records. So record is a block, and these blocks are separated, and these separated blocks are called fields. And it is something like, for a clear concept, record is something like a line, then field will be something like a word. Alright. So by default, it is also separated by a white space, just like word in a line. And $1 refers to a first field, whereas $2 will refer to a second field, and so on. Okay, it goes on until you reach the end of a line. So that means a new line, not the end of a line, but yeah, end of a line, that means a new line. So until you reach a new line character. So NF represents the number of field, that also represents the maximum field, that is the last field, okay, or the latest field, whatever you say. So it defines, or this gives the value of a last field, the last word value. So how fields are separated then? Fields are separated, as I have told you, they are separated by a white space, and they are called a field separator. And you can also define your own. Default field, you can define your own field separator. Okay, they are single one characters or a regular expression. All right. So how do you print the output then? We use a special statement, that is a print, to print the outputs. We can specify the strings of number to be printed in a list separated by a comma. So you can print like item 1, comma, item 2, and it goes on continuously. It depends on the choice part. Okay, also be careful that it's not goes continuously, but it depends on the choice how much items you want to print, and they are all separated by a comma. So here are some particular example of a AWK. I have provided here an example. There is a AWK. If number of field is less than 4, print this line. Content is something. Okay. okay, I can just specify you guys, like I can, let me say, okay, let me print out the awk. But okay, maybe let me check what is in a.txt. There's a 3 fields, so okay, clear it. Awk. Okay, this is a small program, so I'm just executing in this form. I'm not executing in a file. Number of field is less than 4. What do you have to do? Is a print f. What is the pleasant surprise? And print also the first field, that is or a line, and to print the file you pass a.txt, right? But it didn't print anything, right? So why it didn't print anything? Okay, so there was a mistake. It didn't terminate it. Something, right? But it didn't do. Why? Because the number of fields were not less than 4. They were 1, 2, 3, 4, 5 fields were there, right? So it didn't print anything. Okay, so let me change it. It's greater than 4 then. Okay, so look, it's just printing out what a pleasant surprise, and just printing out what a pleasant surprise. Similarly, it's just printing out the situation. You guys can also create your own new line. Yeah, it's working, right? And this is it. Okay, this is just a sample program. And the condition syntax is same as C language. That is, if condition and also printf that you see are all similar, terminated by the semicolon, right? And here is a second example that says that this user pattern so prints the line that contains a string user. Okay, and awk for length of a file of a line is greater than 80, then print every line that is longer than 80 characters. So awk, the number of field is greater than 0, prints every line that has at least one field. Okay, and this prints first field of a password file, or no, not password file, it's of a file. String 1 is just okay, so this one is a pattern that you specify in this, and the pattern is a string 1. So if this string 1 is found, if within this condition, if third field is greater than 0, then you print this, the first field. Okay, whereas this pattern is found, just like I have specified here. So whenever you find pattern 1, perform this action. Okay, so whenever this pattern is found, it performs this action. And as I have told you, the execution is for file is we have to write awk -f as an option, and the awk file you have to provide your own, the awk file and the input file. Alright, so guys, now let's begin our session for the laboratory, and that the labs will be done here. Okay, we have some like 3 of the exercises here. Yeah. Okay, let's begin our exercise number 1. So before beginning, what we are doing here is like we are just practicing like writing C multi-threading applications, right? So by using the pthread library, I'm just trying to use the pthread library here to create a multi-threading applications. Okay, and by using C as a programming language, so you'll also learn how to write a simple awk scripts, and you'll also improve your bash scripting skills. So here what you have to do is in exercise number 1 is like you have to write a concurrent program, okay, which is able to sort data files using thread as follows. So the input file includes something like, on a first line the total number of integer values is there. So on the following lines the number of each line. So first, how many lines, the integer lines are there. So it's like given here, that's 5. So you have 5 integer values like 3, 45, 76, 9, 11, right? 5 number of integer values in the file, and the program reads n input parameters for each couple of parameters. So the first parameter identifies input files, right? So and the second one output files. So then the program creates n by 2 threads. So n input reads n input parameters, so for a couple of parameters. So you guys have to create like half number of threads for each parameters that you create, like each parameter that you include, and each thread reads the corresponding input file, sort the corresponding integer in ascending order, and store the result in a corresponding output file. So reads the corresponding file, reading, sorting, and storing. 3 kind of actions are performed here. Each thread performs 3 actions. Just be careful, like just like remember this concept, that is each thread is providing 3 important functions, that is reading, sorting, and storing. And for example, there is a particular example here, and what it says, like here this is a sort executable file. The parameter paths are 6, that is file in, file out, file 2 in, file 2 out, file 3 in, file 3 out, and it will create 3 kinds of thread, that is thread 1 that is going to sort file in and file 1 in, and it will also store the result in file 1 out. So it is reading file 1 in and then storing it, like sorting it, and then lastly storing the sorted result in a file that out. And similarly it does for like thread 2 also performs the same action, thread 3 also does the same actions, like this. Okay, so let's begin. And here you have some precedence graph of how you should like create a process, and like you might create almost like 3 processes. So 3 times for, yeah, and like you can see here the information is provided here. Now I will just show you the result. Okay, I have written a simple result of those kind of threading application, and this for you guys, this is just for your informatic, this is just done in point of view of information. Okay, just providing you some particular information about how actually does it work. It's like it's not some, for academic perspective or point of view, you guys will not be asked to usually write a thread programming language. Okay, so like thread, do not have to create any kind of threads or write any kind of thread programming language in your exam sessions, maybe, I guess, because this is just for your higher level understanding. Alright, so but the concept is also similar, like this, I mean simple, it's not so difficult. And before going through all these functions, let's go to our main function. What is doing, we declare a thread. Okay, it's passing, the arguments are passed here, and thread arguments is pointed to TA, like just we are creating a pointer to thread arg. And thread arg, this is something like a structure that I have defined here, and this structure is something like it consists of 2 attributes, that is file in attributes and a file out attributes. Alright, so Okay, so now we have some following parameters. Firstly, we check for the arguments, are the arguments passed or not. Okay, so if you pass like 6 arguments, then are they okay or not. Okay, so you have to check are the arguments passed correctly or not. For example, if the arguments are passed like 5, then it's not going to work like. So that's the situation, because 5 arguments means like it doesn't match there, because we need one file for each argument has like each file has file in and file out, and file in and file out similarly, right? It must be an odd number, not an even number, right? Because each thread has file in and a file out. So here the number of threads are to create. So for each number of parameter pass, we divide it, the total number of parameters you have to create like half number of threads. So for 6 parameters passed, 3 threads are created, right? So you loop with this condition, and what you do is you allocate a certain size for this thread arguments that you have pointed here. Alright, the structure of that kind, which consists of 2 kind of attributes, that is file in, file out, and then you print for this structure. You point to that structure and you like print that, print something, print the character, the value, the file to that structure. Okay, print the string to that structure. So also for file out, you print that string, print the string to that file out structure. Alright, like attribute 2, that is a file out. Then lastly you create the thread and you implement the counter after creating the thread. Alright, so here the counter is implemented twice. It must be done like that. And you guys have seen that the thread ID that you have created with the thread, it is address is passed here, the null, and tf is something like the function. After creating the thread, I would go through here that this attribute, this parameter, and for this, for each thread that you create, you have to join the thread to the another created thread, right? And lastly you exit, and like what is this tf, the is something like this tf function is something like it consists of the thread arguments, and what it's doing is like it is first reading the file, it's creating this read file function, and lastly it is also sorting it and calling the write file function. The 3 functions, main important functions are called here. That is a read file function. As you guys know that each thread is performing 3 kind of actions, that are reading the file, sorting the file, and this is all done by 3 kind of important functions. That is reading a file, asserting means something like you guys already know that is something like abort the program if assertion is failed. Okay, if any kind of failure occurs, then it assert or abort the program. So it starts the file and then writes the file, right? So this function is called here, and lastly you free the vector that you have allocated. So memory is allocated, also allocation is also done here. And let's go to the reading section. So in the reading section, in the reading function, it is just going to read the file, that is opening the file, performs the some like traditional steps, that is reading file pointer, opens the file and reads it, and we allocate the amount of memory of integer type. Then we similarly because those file consists of some integer numbers, right? And then what it does is like is scanf for the following information and just like write it back to the this array, that is a vector. Okay, and lastly it closes the file. So and the sorting part is done here. The vector is that it has read is grabbed from this, okay, attributes that is passed through this attribute, that is a vector pointer, okay, that is pointing to this this array, and similarly it just sorts by using double loop, that is for two like it's like a matrix loop, okay, something like that, like two loops, that is four loops, okay, and that is just sorts, performs a simple algorithm of sorting. It compares, firstly it compares between two like vectors, two arrays. So if one array is less than another array, so the greater array, the less array will be sorted with a greater array, and greater array will again go back to the like it just gets sorted, right? And lastly, this writing file, it just opens the file pointer and writes, okay, and then also it prints out the following information to the vector. So it's just writing back to the vector and just closing the file pointer. So this is it. Alright guys, and this is going to work similarly like this. So this was just about a conceptual understanding about how we created the thread, how we joined the thread, and how lastly we exited, and how this thread is performing this action 3 was successful to perform three kind of action, that is reading the file, then sorting the file, and lastly outputting the file, right? And all after creating the thread, we join the thread, right? So understanding point is these two concepts, important concepts, that is this one and this one, okay, and the action is performed is from this parameter, that is TF. Because manual of thread, you guys know that, like, you know, thread pointed to the thread, and the thread attributes, and the void start routing. So the start routing is this one, that is TF. Okay, from here the thread like starts. Okay, so arg is passed as the sole argument of start routing. So the new thread starts executing by invoking start routing. So the thread actually starts, okay, the new thread that you create will start execution by invoking such kind of start routing function. Okay, so it's this one. This is the important concept that you guys have to understand. From where does the thread start execution? It's from here, like from this parameter passed. Alright, so that was about this exercise number 1. Alright, so this is all about how to create a multi-threading application in C programming language. Okay, so right now we are in exercise number 2. We are just using, like, we are just improving our skills for bash script. So we are writing a simple bash script programming language which reads a file name as a first command line parameter and a word as a second command line parameter, right? So the file includes a list of directories, and for this directory searches all the text files ending in .txt extension, and for each file generates statics of 2 files. That is, first file will have extension .stat, and it contains file statics, that is, it contains the number of the lines, number of characters, number of words, and the length of the longest line. And for your kind information, guys, you guys can do this by using WC command, right? Word count for all the files that you will read and look through it. So for the second, with the same file named by ending in .graph, second file is a .graph file that contains histogram, which contains of 2 symbols, that is positive and negative symbol. So positive symbol is in case if the second parameter that you pass is a word. So if the word exists, that means we are going to use a grep, that is, if the pattern exists, then we are going to use specific, like print out a positive symbol. Whereas if the the word do not exist or do not occur, the pattern do not occur, then we are just going to print out minus symbol. Alright, so this is the basic idea, and and both the stat file and graph file are stored in a new directory in the same. Okay, so this is all about our situation here. So okay, let's begin writing the programming language then. All right. Okay, this was not the situation. Okay, let me go to the terminal and let me list. Yeah, we have this test.sh shell file already, so it's also executable already, right? You guys also remember, if you guys have followed my previous lecture, I think you guys have already known that green line green specifies this is our executable file, right? Let's go out of favorite editor, that is gedit, and let's open out. Okay, so there are already some files here included. Let me enter this file. Okay, alright guys, so okay, let's go step by step, and it's a bash script. So where is the situation here? It's a bash script, so always bin and dash is there. Okay, so we have to read a file name as a first command line parameter and a word as a second command line parameter. Okay, so the file includes a list of directories, and for each directory sources all the text files ending in .txt. So while you read what you are reading, you are reading a line. Alright, you are reading a line of a file, and you do something while you read and done. So you pass the first parameter, that is $1. Alright guys, and for your kind information, like the directory, okay, I will wait. You guys also have this file that you pass as a first parameter must contains a list of directories, so you have to provide the list of directories there. Alright, so file includes a list of directories, and for each directory searches all the text files. So there is a directory already. Now for I in the, like, this is the expression, that is a find in the directory, that is this line, find in the directory. What you have to find is like the text file, so the name must be, alright, starting from txt, alright, and the type must be file. You can specify this or not, you can do and done the situation. So what you do here is like, okay, so what you do is like, what you are doing here is for each file that you find from this block of results, that is from this expression, that is find $line from this line that is just read. That means this is a directory. For each line, this line consists of directory and the name and the text file. For this directory, you read a text file. Alright, so okay, so we are in a situation right now that we have to first write a file. First file, we have to generate two statics of file. That is, okay, this is for first file, that is .stat file. Okay, and for .stat file, what you have to do is wc, and you have to give the file name, right? $i, and you have to append it with a file, and the extension should be stat. So we have to get a file name. That means we are using file name will be something like, file name must be something like, we only need the base name. So how do we get the base name? It's like base name dollar I is the file for each file. Alright, so for each file, and I want to exclude this .txt, and this is the base name. And what you do here is like file name, you append it to the file name, and you just say that the also append okay, we have to just the stat, yeah, catchinate with the stat. Alright, so this is it. So what it says is like WC is what you guys already know. The WC command is just going to give you the number of lines, the number of words, and number of characters, right? But what about the length of the longest line? So how do you find it? And also there is a special command for that, also included in option in WC command, that is WC -L is going to give you the length of the longest line. Alright, so similarly we also append this with the same file name. So this information will also be added there. And this is it for the first file that you generate, that's a stat with extension stat. And now this is second file will have a extension graph. Alright, and this second with the same name but ending in a graph containing a histogram made of positive and negative symbols. So right now we have to understand, it's like here we are passing a second parameter, that is a word. We have to check if it is working or not. So for that, while you read what you are reading here, you are reading a word, let's suppose do and done, and for a done you pass a parameter that is a, what do you pass as a parameter is a file, because I is a file. For each file you have to read the words in the file, right? So you have to understand, so you have to pass this file here as a parameter, and this is okay passed here. After you read a file, then you say there is a condition. It consists of the expression that is something like okay, it will consist of something like catenate dollar this file, and it's piped with means it's display the file and breathe. You check the pattern. The pattern must be something like the $2 as a second parameter. Pattern will be specified by the second parameter. And what else? Alright, yeah, this is it. And last you say the word count. Word. Alright, so this is it. What you do is you print the command, then you pipe it with grep, that is grep is checking this pattern. Alright, and then it's piped with word count. So all the pattern that it finds, the word is counted, and this word count will return you how many words are counted here. Alright, and now what else? Now the situation is like I have this word count, so I will check a condition that if this word like equals to 0, can I say such a thing here? If this word is 0, then I can say that, then what you should do is you have to echo it. If the word is 0 means what? If the word is 0 means word count is 0, so there is no match. So what you have to do is you have to also you have to be careful about one situation, that is also we need the counter to increment it, like we need to also read the line. For each line I have to specify it. So what about the line? So let me counter I. Okay, let me define counter I, or I can also say counter equals to counter dollar counter plus 1. So this is a counter, but before this guys I have to also be careful that I have to also counter must be used here. Counter equals to, let's say, 0. Alright, and what is done here is like this counter okay, so this counter, there is a counter, right? So this counter is what this will do is something like just increment the lines, right? So what next? So what should we do now? So we have if $n equals to 0, so that means if this the word count is 0, so there is a no pattern match. So we have to do one thing, that is also specify there is some certain thing, that is not only increment the counter but also say that s equals to something like $C, because this is a counter, that's the line it's going to print out. So then what you do is $s equals to $s. Okay, so minus is printed here. Okay, so it will just echo $s. Alright, so else it will echo $s plus. Alright, so that's it for so let's close the if condition. I guess this is okay. For the initial state, and let me close it. Let me check this situation. Okay, is it working or not? So for that I have, guys check out, I have these two folders that are test1 and test2. So cat1, you will see there are, sorry, it's a directory, it's not a file, so you cannot use cat in folder like folders or directories. So we have these two files there, change directory back to the working directory, change directories to, we also have like these two files here, de, before it was bc, now de. So change directory back to a working directory. Now the situation is like, okay, now let's execute this test.sh. okay, and the first parameter you pass is a file, that is a okay, I will pass is a this one. Let me show you what is this tt.txt file, what it contains. It is a test1 and test2, the directories that I have to include. You guys remember, right? So now let's execute it, because the previous condition was we have to include the file that consists of the directories, and the directories must be listed in the line. So now, and what shall be the word? Let the word be A. Okay, so here is the problem. So I have to just go to, there is an error here. And yes, what I made here, I should have done this. Done. But instead I did do. Okay, here says a line 18, missing that one. Okay, also there is another error. Let's go to line 18. Yeah, and this is missing here. The space was missing there. Okay, just printed out something like this. Okay, yes, I got it. Now we have a small problem, that is this one, that we should have appended it in a new file, that is a file with a graph. Okay, that was our mistake, so that we forgot. So let's append it. And we should not echo it like this. We have to can say something like this. Or you guys can, yeah, we can directly echo here. S minus, and you have to append it with a. Now be careful about the file. So we have to use the same base name file name, but with the extension graph, right? So this is it. Now also you have to append it similarly in that file name, but with the extension graph. Alright guys, so yeah, let me check out if the situation, yeah, I think it worked. Let me check out, yes, we have generated this kind of files that are aa.txt, bb.stat. No, this is the file that we provided. This is a different file, but look, for each file it has generated the stat and the graph. Where is b? b.graph. Okay, if you go and check out bb.stat, you will see certain information that are something like information like this one. This is appended 3 times, okay, but I will just show you again, like let's remove it again and let's do it again. Stat, I guess it has appended many times for all those files, so let's remove all the files. Also remove the but okay, yeah, it was there, but also let's remove the graph. Done. Now let's put something there. Okay, it was that something like Oh, sorry, yeah, it was not C actually, it was a counter, right? So this was the mistake here. Okay, also be careful about this situation. Now let's go back here. Now here this. Okay, now nothing is there. Alright, so when I execute this command, that is test.cell, I pass this file, that is txt file. It consists of folders, name of the folders, and now if this one, if you check out, we generate this kind of files. So if you go and check out the information that is inside bb.stat is this one, that is first, the word, and second is the first is the number of lines, second is the number of words, and third is the number of characters, and lastly the longest, the length of the longest line is printed here, that is 16. Alright, and similarly you can also check out for all. It's like ccc.stat, the longest name, and word count, character count, and the number of lines. Okay, and now let's check about the graph. Get dvd.graph. Yes, look, all these words consist of this positive, means only one. This A is present in line 1, line 2, line 3, line 4. Okay, so if you go and check out, also here A is present. Cat also here is present. Yeah, also here is present. So all this line is present there. So alright, so you guys just go and try this by yourself. Okay, so that's it for this kind of this bash script. So you guys, if you go, guys, follow me through and just write this program by yourself. You guys will understand by practice. Alright, so now we have exercise number 3, and what we have to do is we have to write a simple awk program. Perform the following task, that is print the name of the initialization process, the first process executed with PID 1. So how can this be done? Okay, let me go through here, let me clear the screen of the terminal. Then here the hint says that EL is going to provide you this kind of list of the information, that is the time, command, TTY, the terminal that is using, WChan, size, address, NI, PRIC, PPID, parent ID, process ID, user ID, ASF. Alright, so just ignore some information that you do not understand, but just remember is what it says, print the name of the initialization process. So you have to print this name. Okay, the first process actually PID 1. Okay, how it is done is, okay, let me go through here again, go to the end, clear this. What is done is up, and what is we have to write is if $4 or okay, let me first let me explain your handle. The strategy is this one. Okay, the strategy is to go through the fields, that is, this is the first field, second field, third field, fourth field. So I have to check the fourth field, print the name of the initialization process. The first process executed is PID 1, so I have to check PID, there's a fourth field equals to 1. Then I have to go to the last NF, that is the number of field, the last field. Alright. Awk. if condition is $4 equals to 1, print $10 F. But before that, this is passed only after this command is passed as a pipe. Alright, look, it just printed out this. Process EL is piped through this AWK and we printed out the init process, that is this process with the PID one. Alright, this is the way how you do it. Now clear this. Now let's go to print the name of the PID of the process, which status is R or R plus. Okay, so how can this be done? PS, manual PS. So PS has following formats. Okay, information about the threads. PS ELF. So the status. If the status will be represented by and will be shown or represented by this PS underscore ELF. So let's check out that. Alright, so is there any information about the status given? I don't think so. But let's check. So it's not about the PS ELF. But I think it's not a ELY. Let's try that one. Maybe it doesn't. Also here the status is not provided, right? So I don't know how to. Okay, let me go and check out like from where can we get the status information about the status of PS. Maybe this one. Let's try here. Yeah, ELA actually. Okay, so okay, is it given? Also here the status is not given, right? Strange. Okay, so I think you guys, it's not needed, okay, because you cannot display actually you cannot print any the process ID status. Okay, so that's the problem. It's not. So you can. Also here there is no status of R or something like that, right? So that's a problem. Alright, so we just guys just try And that's it for today. Actually, let me check. No, you cannot print the status here. So that's the problem. So just it's okay. We are done with till exercise number 3. All right. So let me clear this screen about the terminal. And what you guys have to do is like just practice. Okay. This is the key of understanding the AWK programming language. And right now, for summary, what you have understood is to write a simple multi-threading application in C programming language, and you also have improved some understanding about bash script and AWK script, right? So we'll go through AWK script much more in detail in our next lecture. So thanks for listening, and see you next time. All right.